Hey everyone, and thank you for coming to watch my talk today. In the next half an hour, you'll get a real-life case study of improving security posture of the software supply chain. The use case in this talk is based on the backend services, but the core principles are applicable to the front end as well. My goal is to give you something that you can use as a framework for your own cases. And if you were just thinking about improving the security of the supply chain, that was your sign, do it. Let's start with an introduction. My name is Serhii Vasylenko. I'm a software engineer at Grammarly, and this is my 5th year at the company with 13 years of experience in the industry in total. I took on different roles throughout my career, from individual contributor to engineering manager and tech lead manager, and then back to individual contributor. This gives me quite an outlook on how things run in the organizations. And all this time, no matter the role, my focus areas were CI/CD, developer experience, and security automation. We will get to the agenda in a moment, but before that, I wanted to say a few words about my colleagues who worked with me on implementing all things I'm going to talk about today. Kudos and warm regards to Sasha Faust, Vladimir Suslenko, Sara Vahulets, and Yarasul Altai for their incredible work. Now to the agenda. We will start with why. Why should we bother about the supply chain at all? Then we will go straight to the outcomes that our company got after we addressed the subject and to the challenges we faced. Next, to the central part, the detailed overview of the main lifecycle stages of the software, build, deploy, operate, and security controls we should apply there. And at the end, we will review the key takeaways and we'll have some time for Q&A, of course. So to set the stage, we're starting with why. I want to give you 3 examples first, some well-known and some very fresh. So in December 2020, SolarWinds, a trusted vendor providing IT monitoring software to more than 33,000 of companies, had been compromised. Attackers had infiltrated their build system, inserting malicious code that was then digitally signed and distributed as legitimate updates. This incident affected major tech companies and government agencies, costing billions in damage and remediation. Just a year later, in 2021, the Log4Shell vulnerability in a widely used Java library created another industry-wide crisis, showing how a single vulnerable component deep in your software supply chain can put millions of applications at risk. Now, fast forward to January 2025, like a month ago, when a type squatting attack on the long-time deprecated BoldDB Go package was discovered. The attacker mimicked the BoldDB package via type squatting to trick developers, and they cached malicious code in the Go module proxy, ensuring its persistence even after modifying the repository to hide malware traces. Surprisingly, about 9,000 projects still use this deprecated Bold module, hence are vulnerable to this attack. So at Grammarly, we take this seriously. We believe that our software is the only as secure as the components we use in our build processes and systems. So the last time we ran the internal audit, we discovered that 96% of detected vulnerabilities were attributable to the supply chain, one way or another. Our security posture has a direct impact on our business. We work with users' texts, so we must be super cautious about the systems that work with the data. These measures help us win security audits and contracts with commercial and governmental organizations. But this also applies to the individual customers because we use a multi-tenant architecture. So either we assist in writing to someone from the federal government or to a student, for example, we must keep the security bar very high. To support my previous points, I wanted to jump right to the challenges and outcomes we got. So the rest of the talk would make more practical sense to you. Like with many other companies, our tech stack is wide and goes through many evolutionary changes. We want to support innovation and the speed of our engineers. So they are they have quite minimum of limits on how to set up their CI/CD configurations or choose a framework for the next project. That comes with a price, though. CI configs differ from project to project. For example, there are numerous possible ways to name a build job or a deploy job or even a stage where this job happens. The number of languages and frameworks is big, and the number of projects and AWS accounts where they are hosted is much bigger. Such a diverse palette of everything sets a real challenge. Like, how can we apply the same security controls across all that? I will start explaining how in a moment. Let's see the numbers first. This is the data as of January 2025, a few months after supply chain controls were applied. Since the rolling out, we've got about 59% drop in critical vulnerabilities in runtime. 90% of security patches to the source code are applied either automatically or with the click of a button. We covered all backend services with the security controls, either in blocking or audit mode, depending on service network exposure and some other factors. And we have zero security issues in runtime that were addressed slower than is required. Having that in mind, let's see how we achieve this. We've built our entire security approach on top of 4 key pillars: reproducible security, automated reasoning, automated remediation, and developer experience. We make security reproducible by turning security controls into reusable code that runs the same way every time. Think of it like infrastructure as code, but for security controls. We create or integrate solutions that automatically understand context in addition to security scanning. They map relationships between resources, and they make security decisions based on the real-time data of our environment. We remediate security issues automatically through code updates, standardized fixes, and built-in security patterns, all that to reduce the manual intervention. And we know that developers are the primary users of security tooling. They are our customers and the target audience, not the companies that perform the audit of our infrastructure of the software. Therefore, we create all our solutions with maximum attention to developers' productivity, awareness, and ability to make security decisions on their own, again, with minimal intervention from security teams. Now, let's dive into the details, and we will start with the build phase of the software lifecycle. Of course, it all starts with the source code and we create and the things we use for it, like third-party dependencies. To address the security of third-party dependencies used in the source code, we applied Renovate. It is an open source and free-to-use tool, and we added a bit of our own orchestration around it. Our automation runs Renovate against the repositories, and Renovate creates pull requests. We define 2 kinds of such PRs, security and updates. And we try to group related changes semantically to optimize the number of PRs. If it's a security PR, the PR will get merged as soon as its pipeline succeeds. Or our internal policy dictates that all our PRs must be explicitly approved. So to keep things automated for Renovate, because each PR must be approved, we use a robo-user to approve such PRs instead of real people. Let's take a closer look at the architecture diagram to better understand how it works. And I want to remind that we use AWS and GitLab, so I will be using some terminology from these systems. A Renovate pipeline is scheduled to run every 2 hours, and it consists of 3 separate jobs: generator, runner, and status. The generator job queries GitLab and collects the list of all active projects there. It puts the list of projects to the SQS queue and kicks off the runner job. The runner job spawns 20 copies at once, so each runner processes 1 project from the queue at a time, locking it in the queue while processing and removes it from the queue when done. This is where Renovate actually does what it should. Every CI job starts Renovate container for a given project to analyze and create pull requests with updates in case of need. And when all the runners finishes their work, the status job starts and checks the SQS queue to see if we have anything left unprocessed in that letter queue. If we do, it will send a report for us to analyze what went wrong. And there is a separate process with a separate schedule that runs with AWS Lambda to approve security PRs created by Renovate and set the PR to merge automatically if all its checks succeed. So all that works unattendedly and helps us keep the source code secure across about 600 repositories. The next point is the way how we ingest the third-party dependencies during the build process. I want to highlight the importance of the centralized dependency management here. If you want to set up such a sink and implement it for several reasons, they are such as like, this will give you a single place to control third-party dependencies lifecycle. Like, for example, you can automatically prevent the usage of end-of-life software. Another good reason to have such thing is that you can enforce standards and policies. Like, for example, ensuring that Docker tags are immutable or specific projects use segregated spaces to store their build artifacts or dependencies. Then, when it comes to investigations, it is much easier to track and lock vulnerable components and much more of that stuff, giving you the power of control over the crucial link of the whole chain. There are many vendors on the market. Some popular ones are JFrog, Harbor, Sonatype, and Cloudsmith. The cloud vendors also provide their built-in solutions of the similar kind with a bunch of implementation guides like AWS Elastic Container Registry. Google Cloud has similar stuff, Azure as well. It is a good thing to start if you don't want to pay extra for other vendors. We picked JFrog Artifactory, and here are the controls we applied to it. Artifactory has a set of team-specific repositories for different package types. There are also a few of common repos for things like base images and shared libraries and such kind of things. We proxy all third-party dependencies through Artifactory, Docker images from Docker Hub, NPM packages from npm.js, all that stuff. Engineers cannot push anything to Artifactory from their laptops. They can only pull or read. And it's not a problem for a local development because you need to download something locally, build it locally, and run it locally. But if you want to go farther than that, there is CI that is allowed to push and store the artifacts. For CI, there are separate users with separate access tokens used to push the builds or pull them during deployments. And to bring all that to even higher level, you might consider locking down the CI to block the outgoing traffic to the internet. So effectively ensure that your centralized dependency storage is the only thing that can be used as a source of dependencies. For this thing, we are not there yet, actually. We had a successful pilot with Cilium and Kyverno. We run CI and Kubernetes, but then postponed its full implementation in favor of other controls. But we will get there anyway. And we will, of course, apply a set of like allow listed things, such as external services for end-to-end tests and maybe some edge cases where Artifactory cannot proxy something. But the things I just explained are actually applicable to any other similar system, not just to Artifactory. Now, before we move to the deploy phase, let's quickly recap what we've learned about security of the build phase. So we use Renovate to automatically update and patch dependencies in our source code, and we centralized all our dependencies through Artifactory, giving us control and traceability. With these foundations in place, let's see what controls we need for the deploy phase. But again, some challenges ahead, right? So you want to scan the Docker image that is to be deployed. And remember, I mentioned flexibility and non-standardized CI configs, all the stuff. This is where it plays out. Questions like, what is the name of the job that deploys to runtime? So where should we like check for something? Or is it a production deployment or QA deployment? Or stuff like this. It is all complicated at the first glance, yet still manageable. So first of all, despite us being agile and everything, we still have some standards, of course. And there is one that helped us a lot. The deployment tool maintained by our engineering platform and used across all teams to do the deployments. As you already know, we use GitLab, and GitLab has the feature called compliance framework that allows you to define the actual pipeline configuration of the project. But you want to be very careful here, keeping in mind that each project does CI differently. You want only add something on top of users' configs, so not to break things. Then there is our security scanner, Wiz. Wiz is an awesome cloud security platform that offers a centralized way to manage many security-related things in your cloud and code base. Here specifically, we integrated their CLI version of the scanner into our deployment tool. And with the power of compliance framework, we can propagate certain environment variables to orchestrate the scans and security gates. For example, whether to run scan for specific project or project group before the deployment, what scan policy should we use, blocking or audit, and many more. Our deployment security gate is by default. We do the scan before the deployment happens, and we validate the Docker images on the server side. So from the server side, there is an admission controller that validates the incoming images. And there are two conditions for it. An image must come either from designated Artifactory registry or from trusted vendor registries for kube add-ons and things like this. Also, for images built by us, it must be recognized by Wiz as successfully scanned. There is an attestation mechanism behind. When each image digest is mapped to the scan results, Wiz verifies that information to make the final decision, deploy it or not. In other words, we integrated Wiz admission controller to this stuff. So let's look at the architecture diagram to understand the deployment controls better. It's a bit complex maybe, but I'll try to explain it anyway. So from left to the right, it all starts from CI/CD pipeline triggered by PR or a commit to the main branch. Sooner or later, we don't know when, because again, different names and everything, but it will, as a deployment tool kicks in, right? In our case, this is a standard way to deploy images, and the tool called Platform CLI. So inside Platform CLI, there is a security scanner that triggers before the actual deployment and it scans the Docker images specified in the deployment manifest. It's a security gate, kinda. So if the scan fails, the deployment will not happen. The scanner runs with CLI, which scans the image or images and communicates with Wiz Cloud, sends metadata about the image, scan results, and stuff like this. Then there is a decision part, where scan results is evaluated against the policy settings and also our custom ignore list. It's a feature still not implemented by Wiz for images, and the way to opt out from specific CVEs should they be considered as accepted risk for specific case. Despite the final status of the scan, we always send the feedback to pull request or job logs to let users know how things are going. And if the image is good to go, it's like secured, we proceed to the actual deployment. Then we have two backends configurations, ECS and EKS. ECS stands for Elastic Container Service, this proprietary orchestrator of Amazon, and EKS, Elastic Kubernetes Service. So for Elastic Container Service, it's done right away. It's a simpler system, doesn't have much of integration capabilities, and we don't have such a critical stuff there. But for Kubernetes, we promote the image to the clean room registry first, and then there is admission controller that validates the image from the cluster side. This is another security gate in that phase. To support engineers in emergency situations, we have a special way to bypass the blocked scan by adding an environment variable to the pipeline if they have no time to fix something. And this is how it works. Before we switch to the last phase, operations, I wanted to share some things we learned about from creating and rolling out these deploy security controls. So again, the main idea here is to warn users about vulnerability and engage them to resolve it, like not just block them. In other words, we kind of say, hey, there is a tech debt ahead, like critical vulnerability. Resolve it earlier, please, to avoid later work. We learned that sometimes delivery is more important than anything, of course, and sometimes security scanners can be wrong. So there are two things. adjustable ignore list on project level, so users can exclude some CVEs, so not to trigger the scan failure, and guided break the glass procedure to bypass the scan failure and deploy the image in urgent case. Furthermore, we learned and battle tested 3 valuable lessons on strategic partnership. Involve your customer to design the solution with you, for them. This is simple but very powerful instrument. Roll out your security controls in phases, start small to catch the most impactful bugs, and use your infra or platform teams as enablers and cooperate with them more to achieve better results. Let's summarize our controls again before moving forward. So in addition to automated code fixes and artifact management, now we implemented dual security gate, pre-deployment scanning, and server-side validation of the Docker image. We provided developers with tools like ignore list and break glass procedures to be agile when needed. Now, with that we understand how secure both build and deployment, let's move to our final phase, operations, where we need to maintain the security posture in runtime. Your service is running somewhere. This environment has its own configurations and settings. And more to that, if yesterday your security scan showed 0 vulnerabilities, today the same software might have one, right? Because they are discovered like every day. But knowing that there is a vulnerability is not enough. You also want to understand how bad it is. This is when a vulnerability becomes an issue, analyzed against several factors and ranked by severity. And this is why contextualization in runtime a crucial role. And this is where cloud security platforms such as Wiz help a lot. When vulnerability is discovered in runtime, Wiz helps to understand things such as network exposure, attack vector, likelihood, and other factors mapped to the state of our environment. All that automatically, and all that with the ability to use a bunch of native integrations or custom ones through their API. And yes, we use their API a lot. So having an issue on hand is good, but it needs to be resolved. This is when SLA-driven ticketing can help. The SLA here is a kind of contract between the security team and other teams, ensures addressing the issue on time with high priority. We use a few custom lambdas to do the automation for tickets and notifications. We use Jira for ticketing, and we use cartography service with few custom scripts to define the owners of the applications and send Slack messages with instructions. Cartography is a tool that consolidates cloud resources and relationships between them in a form of a graph with clear dependency paths. It is free and open sourced. And we alert security team if there is an out of SLA ticket, so they could apply the intervention policy. The point of that thing, intervention policy, is that when there is an issue that wasn't addressed in time, security team should step in to help and engage the owners of the affected service to deploy the fix. So security team reviews and approves all pull requests for that service, making sure that all efforts are addressed to this issue resolution. Yet runtime issue assessment and response systems are the reactive measures. This is why it is super important to have also it combined with proactive measures and controls such as we discussed before. At the end, I'd like to enforce few things from the talk. So there are 4 pillars of security automation that can be treated as a sort of framework that helps you build security controls for supply chain. Reproducible security. Security controls as code, predictable, reusable, and consistent. Automated reasoning, smart systems that understand context and relationships to make better security decisions. Automated remediation, fix issues automatically, fix them fast, and without human intervention. And developer experience, involve developers as early as possible to design solutions for them. Cooperate with infra and platform teams to implement solutions together. As we wrap up, I wanted to leave you with one final thought. Your software is only as secure as every link in your supply chain. From the code you write, through the dependencies you use, to what actually runs in production. We've seen how combining proactive controls with developer-friendly tooling can transform supply chain security from a difficult challenges into something manageable and automated. And I hope you take these practical insights back to your organizations and adapt them to your needs. I've truly enjoyed sharing my experience with you today, and I'm excited to continue this conversation in Q&A or Discord. Thank you.
Oh, thank you, Sergey, for this presentation. You're just on time, really quick, and really great thoughts. I have just a couple questions from my side. Want to hear your thoughts. What are the most common weak points in a software supply chain, and how can automation help to mitigate them?
Yeah, that's a great question. I guess, well, I mean, like, I will start from short answer, it depends, but for example, I guess the the most common one probably these third-party dependencies we ingest, and this is why it is crucial to scan the final artifact before the deployment to see what's actually going to the production. And the important thing here is the pre-deployment scan, because sometimes you might actually have some bad stuff in your code base, or okay, not bad stuff, like vulnerable stuff. We're talking about like vulnerabilities, right? But not all of this will go to prod or even somewhere, or even QA. Sometimes there is just dev tooling that you run, you do this locally. Okay, it's maybe some old package or whatever. It works for you, but it's vulnerable, but it doesn't go anywhere. So it's kind of okayish. So this is why you need also to distinguish between like source code scanning and like artifact scanning, because source code may contain more of stuff, but again, not all the stuff goes to prod. Uh, so like this third-party dependencies and but yeah, I guess I'll stop here because mostly this all comes from this outer world. Of course, there is SAST scans that to ensure that your own code, that business logic is not vulnerable here. But I skip this in this topic because it kind of touches a bit different things. So yeah, third-party dependencies and of course your own like business logic.
So we need to be very careful when we are using third-party dependencies, yeah?
Yeah, you do.
Okay, okay, and there is one more question from our audience. Mikhailo is wondering, have you measured how fix fast affected time to market and delivery?
Oh, that's a good question. So if I understood it, like how fix fast, like if we fast something with Renovate, for example, right? And how it affects.
Hmm.
Yeah, so we did not measure this particular thing. We do have metrics for time to delivery and merge request approval, so like all these developer experience metrics. We do not have the particular ones that distinguish or like picks the exact like points of all this inbound like things like mesh security fixes or something like this. This is a good one. Thank you. Yeah, we should do this, I guess.
Yeah, there are a lot of metrics that should be measured, but it's never enough.
Yeah.
You always could do better. Okay, just to recap, how do tools like Renovate and Wiz enhance security compared to traditional approaches?
Can you define traditional approach?
Maybe just to. Okay, just what you used before. Okay.
Ah, okay, okay, got it. Yeah, so I'll answer this way. So it's actually a never-ending story. I wouldn't be surprised if next year we say, "Hey, we don't use Renovate, we use something else now." It's not about the tools; it's about the approaches, actually. So before
Mm-hmm.
Viz and Renovate, we used built-in tools from GitLab, because GitLab
Mm-hmm.
actually has a lot of stuff for this and out of the box. However, we like based on our experience, based on like numerous factors, we saw that it's not enough. Sometimes it's too much of like false positives. Sometimes it's not enough. For example, now like GitLab again, when you analyze just the source code or artifacts or everything, before it gets to a runtime, you don't know the context. So you actually still need to see how all this plays out then when it runs somewhere. Even if it's vulnerable, it's not always like super duper bad, because if it's a service not accessible from the internet, for example, it's not the same case when it is accessible, right? So it's different. So yeah, so like I guess the main thing here is to never stop of exploring this topic, and always question your solutions, like every half a year or something, like just review your decisions and see how things are working. And it's not about tools, it's about like approach.
Okay, thank you for that answer, for your thoughts, and maybe you can share something of your real case. Have you had ever some vulnerabilities due to third-party libraries, third parties that you used, or now, according that you're using all the modern approaches, you're just safe enough and haven't had any?
Yeah. I will answer this. So I will maybe skip some details, but the thing is
No,
that
please dive in.
I mean, as much as I can. But the thing here is that this SLA tickets I mentioned is actually like auditor firms, like everyone, I mean, I hope everyone, like, but most of the companies, they understand that any, like this game, like security versus the outside world, it's like you're always in the losing position. So you can never be secure for like 100%. There is always a way to hack you. And the question is how fast you can discover this way and how fast you can remediate it. So of course, we do have critical level of vulnerabilities in production time to time, but there is the agreed SLA to fix them as soon as possible. And this is accepted by our auditing firms and stuff like this. And we've never had a hacking incident, knocking on the wood. So that's the case. I mean, every software is vulnerable because every software has a bunch of undiscovered vulnerabilities right now. So yeah, that's my answer.
Okay, thank you so much. Yeah, I've got it. And there is another question from Rostislav. How many security issues by types like critical, minor, do you find on my monthly basis?
Okay. I would say the last thing I remember is 17 of Crete, and about, but again, I will maybe, because defining this Crete high medium from issues is not the same as from CVE scores, for example, but still to answer. So it was 17 Crete and something 60 high, I guess, and yeah, some I don't remember about mediums or something like this. And but teams are doing great. I mean, this SLA's agreement works very well. Plus, some of these issues can be solved because again, if it's about runtime, so it, like when you have this Docker image that is battle tested and scanned and okay, it's clean, everything is well, it goes to some server. And this is like another world now, right? Because there is operating systems, there is container runtime, there is, all that stuff. So of course, sometimes we discover, and this is where this systems like Wiz, actually not only Wiz, like Sneak, another good example, like many vendors do this. This is where the systems help to actually see the big picture. It's not only about your particular Docker image then. So when it's in runtime, it's about like everything, this where it runs. So if we find like the 17 or 60 I mentioned before, it doesn't mean that it's like in the images. It's sometimes, and in most of cases, about this OS patches we need to install, and we of course address it right away, or things like this. Plus, again, as I mentioned, like if let's say we deployed something 2 days ago, it was clean, but like today something happens and the new vulnerability discovered. So we get an issue for ourselves. So as I said, it's never ending game and you always lose.
Thank you so much. And Rostislav said that really 17 critical issues is really a lot. So it's really, we should think about investing money on it if you're a big company. And just for me, if you find some critical issue in the third parties, but you have developed some code and you've started to implement some feature, or what will be your steps? So you just need to rely, or you'll need to find another library, or you will ask to fix some issues in that library, or you would do it by yourself.
Yeah, a good question. So I would say, like, if there's something that let's say we have some package, third-party package, and we use version, let's say 1.1, and some critical vulnerability discovered there, we must update it to 1.2. But this is a breaking change. What should we do? Well, like we will do our best to refactor this, to support this thing. Or if, let's say, vendor doesn't, because we had these cases when vendor did not provide the update for some time, and we communicated and coordinated with this third-party vendor of this particular package or whatever. We contribute to open source a lot. Maybe we could do more, but still we do. And sometimes this is the way we can solve it by ourselves and help other companies as well. So really depends on the situation and the criticality of this thing. So it's really important and critical. Well, we do all we can to address it as fast as possible.
Okay, thank you so much, and really thank you for contributing to open source and making this world a little bit more secure. And just one as the last question, how do you handle operation system kernel critical issues?
Yeah, so the same approach basically, but for example, if there's something discovered it's about ownership and the system we use to define like whom to cooperate with. Like if there is a vulnerability discovered in some underlying layers, like operating system or container is running, or blah, 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 we communicate with platform team, and platform team has a special process actually to ship security hardened, scanned AMIs, again from AWS, like base images for operating system. So it's kind of simple, but I mean, to explain, I guess, it's just we contact platform team and say, hey guys, there is a problem, let's fix this. Yeah, we start this new AMI build process, we create new AMI and ship it and redeploy stuff, just like that.
Okay, thank you. Thank you for that. Really, I haven't thought about such problems as you explained and covered in this topic. I have never sort of just used third-party libraries and hope that everything will go okay without some critical problems, and hopefully it works like this for most maybe of companies, but when you're enterprise and when you need to provide some SLAs for your companies, it is really necessary. And thank you one more time for making the world secure, I would say like this. And
Thank you.
guys, thank you for all your questions.